Hi guys, welcome to my channel. In this video, let me explain the syntax directed translation for Boolean expressions. In compiler design, the Boolean expressions are mainly used to control the flow of program. In this presentation, we will see how a Boolean expressions are translated into an intermediate code using the labels, jump instructions, shortcuts evaluation, and backpatching. Let's go in detail with the slides and let's understand in detail the agenda of today's presentation. In this presentation, I will first introduce the Boolean expressions and syntax directed translation. Then I will discuss the grammar used for Boolean expression and how a relational expression are translated. After that, I will explain true and false labels and the concept of short circuit evaluation. Next, we will see the translation of and, or, and not expressions with an examples. And finally, I will discuss the intermediate code generation, backpatching and its advantages, application. And finally, we'll end up with the conclusion. Let's go with the slides. Introduction to Boolean expressions. A Boolean expression is an expression whose result is either true or false. These expressions are very important in the programming because they help the program to make the decisions. For example, the expressions such as A is lesser than B or X equals Y compare the value and produce the Boolean results. More complex expression can be created using the logical operators such as and, or, not. The Boolean expression are commonly used in the conditional statements and loops. That is, if statement, if else statement, and loops like while, for, and conditional branching. I hope you guys understood. Let us move on to the next slide. What is syntax directed translation? A syntax directed translation is a compiler technique in which a semantic actions are associated with the grammar production. The grammar defines the structure of the program, while the semantic action defines what should be done when the particular grammar rules is recognized. SDT is useful for tasks such as type checking, expression evaluation, symbol table generation, and especially intermediate code generation. Move on to the next slide, that is why translate Boolean expressions. A Boolean expression controls the execution path of a program. For example, if-else statement, the condition determines whether the program executes the true part or the false part. Therefore, the compiler must translate the Boolean condition into an intermediate instruction. Usually, this is done using the conditional jump, unconditional jumps, and labels. I hope you guys understood. This is the intermediate representation. You can see if A is lesser than B, go to the L1, go to L2. L1 is like this, X equals 10, go to L3. L2 is like this, X equals 20. This is the intermediate representation. I hope you guys understood. Let us move on to the next slide. Boolean expression grammar. This slide shows a simple grammar for Boolean expressions. An expression can be formed using a logical or, logical and, logical not, parentheses, or relational operators. For example, A is lesser than B is a relational expression, while the expression such as A is lesser than B and C is greater than D combines the multiple Boolean expression using the logical operators. You can see the different operator and those symbols so that you will get an idea. I hope you guys understood. Let us move on to the next slide. True and false labels. While translating the Boolean expressions, the compiler uses the two destinations, a true destination and false destination. E dot true represents the location to which the controller should go when expression E becomes true. Similarly, E dot false represents the location to which a controller should go and when the expression becomes false. These labels helps the compiler to generate the correct control flow. I hope you guys understood. Let's move on to the next slide. Translation of relational expressions. This is the grammar. A relational expression compares the two values using the operator such as less than, greater than, or equal to. For example, A is less than B. During this translation, the compiler generates the conditional jump. If the condition is true, the controller goes to the control label. Otherwise, the controller goes to the false label. This is the basic building block for translating more complex Boolean expressions. Short circuit evaluation. Short circuit evaluation means the compiler evaluates only the necessary part of the Boolean expression. For an AND expression, if the first condition is false, the compiler expression is already false. So the second condition does not need to be evaluated. Similarly, for an OR expression, if the first condition is true, the complete expression is already true. So the second condition can be skipped. I hope you guys understood. So OR means basically it will do the plus operator, where AND means basically it does the multiplication operator. I hope you guys understood. Let's move on to the next slide. Short circuit evaluation for AND. In an AND expression, both conditions must be true for the final result to be true. Therefore, the compiler first evaluates the first expression. If it is false, the controller immediately goes to the false destination. If it is true, only then is the second expression evaluated. This avoids the unnecessary computation. I hope you guys understood. So, AND basically does the multiplication operation. I hope you guys understood. Let us move on to the next slide. SDT for AND expression. For the production E produces E1 and E2, the first expression is evaluated first. If E1 is true, the control moves to the new label where E2 is evaluated. If E1 is false, the complete expression becomes false immediately. Therefore, the false destination of E1 is the same as the false destination of the complete expression. I hope you guys understood. Let's move on to the next slide. Example of AND translation. In this example, we have A is lesser than B and C is lesser than D. The first compiler checks whether A is lesser than B. If it is false, controller directly goes to the L false. If it is true, controller moves to the L1, where the second condition C is lesser than D is evaluated. If the second condition is true, the controller goes to the L true. Otherwise, it goes to the L false. This is for AND. I hope you guys understood. It is very simple and it is very clear. Short circuit evaluation for OR. In an OR expression, only one condition needs to be true. Therefore, the compiler first evaluates the first expression. If it is true, the controller immediately goes to the true destination. If it is false, only then does the compiler evaluates the second expression. This reduces the unnecessary evaluation. I hope you guys understood. Let's move on to the next slide. SDT for OR expression. For the production E produces E1 or E2. The first expression is evaluated first. If E1 is true, complete expression is also true. So the control goes directly to E dot true. If E1 is false, the controller moves to the new label where E2 is evaluated. The final result depends on the result of E2. You can see here. I hope you guys understood. Let us move on to the next slide. Example of R translation. In this example, we have A is lesser than B or C is lesser than D. The compiler first checks A is lesser than B. If it is true, the complete OR expression is true. So the control directly goes to the L true. If it is false, the control goes to the L1 where C is lesser than D is evaluated. Depending on the result, the controller goes to either L true or L false. SDT for not expression. The not operator reverses the result of the Boolean expression. Therefore, instead of generating the complete new code, the compiler simply exchanges the true and false destination. If the original expression is true, the not expression becomes false. If the original expression is false, the not expression becomes true. Let's move on to the next slide. Example of not translation. Consider the expression not A is lesser than B. Normally, if A is than B is true, the controller would go to the true label. However, because of the not operator, the destination are reversed. If A is less than B is true, the controller goes to the L false. And if it is false, the controller goes to the L true. I hope you guys understood. Parenthesized Boolean expression. Parenthesized are used to define the grouping or order of evaluation in Boolean expressions. The expression inside the parenthesis is translated as a normal Boolean expression. The true and false labels are passed to the outer expressions. Parentheses are especially important when and or operators are combined in a single expression. You can see here. This is how the parenthesized Boolean expression is defined. I hope you guys understood. Complete Boolean expressions. This slide shows the control flow of an expression. A is lesser than B and C is lesser than D or E is lesser than F. First, A is lesser than B is evaluated. If it is false, the entire expression is false because this is an AND operation. If it is true, the compiler evaluates the C is lesser than D. Since this is the part contains an OR operation, if C is lesser than D is true, the complete expression is true. If it is false, then the compiler evaluates the E is lesser than F. I hope you guys understood. Let us move on to the next slide. Intermediate code for complete example. This slide shows the intermediate code generated for a complete Boolean expression. First, A is lesser than B is checked. If it is true, the controller goes to L1. Otherwise, it is false. It goes to L false. At L1, the compiler checks C is lesser than D. If it is true, the controller goes to the L true. Otherwise, the controller moves to the L2, where E is lesser than F is evaluated. This code clearly demonstrates the short circuit evaluation. I hope you guys understood. You can see the labels L1, L2, L true, L false. L1 is basically for the evaluates the second part of AND. L2 is evaluates the second part of R. L true, complete expression is true. L false, complete expression is false. I hope you guys understood. Let us move on to the next slide. Boolean expressions in if else. Boolean expression translation is commonly used in if else statement. In this example, the compiler first evaluates the A is lesser than B. If it is true, it checks the second condition, C is lesser than D. Only when both conditions are true does the program executes the X is equals to 1. If either condition is false, the program executes the X equals 0. I hope you guys understood. Let's move on to the next slide. Boolean expressions in loops. Boolean expressions are also used in loops. In this example, the loop continues only when both conditions A is lesser than B and C is not equals to D are true. If either condition becomes false, the controller exits the loop. After executing the loop body, the control returns to the beginning and evaluates the conditions again. Introduction to backpatching. Sometimes, while generating the intermediate code, the compiler does not yet know the destination of the jump instructions. In such cases, the compiler temporarily leaves the destination blank. Later, when the correct target addresses becomes known, the compiler fills in the missing destination. This process is called as backpatching. Purpose is to handle the unknown jump destination, as I mentioned, supports the one pass code, as I mentioned, useful for Boolean and control flow statements. Let's move on to the next slide. Backpatching functions. Three important functions are used in backpatching. Make list creates a new list containing an incomplete jump instructions. Merge combines the two lists of incomplete jumps. Finally, backpatch fills the incomplete jump instruction with an correct target addresses. These functions make it easier to generate the code for the complex Boolean expressions. You can see make list I, merge P1, comma P2, backpatch P, comma I. I hope you guys understood. Backpatching for OR expression. For an OR expression, if the first expression is false, the compiler must evaluate the second expression. Therefore, the false list of the first expression is backpatched. The beginning of the second expression. The true list of both expressions are merged because of either expression is true, the complete OR expression is true. This is the main idea. You can see B1 is false, evaluates the B2. B1 is true, complete expression is true. B2 is true, complete expression is true. B2 is false, complete expression is false. I hope you guys understood. Let's move on to the next slide. Backpatching for AND expression. For an AND expression, the second expression is evaluated only when the first expression is true. Therefore, the true list of the first expression is backpatched to the beginning of the second expression. These list, the false list of both expressions are merged. Because of either expression is false, the complete AND expression is false. This is the idea. You can see B1 is true, evaluates the B2. B1 is false, complete expression is false. B2 is true, complete expression is true. B2 is false, complete expression is false. Let us move on to the next slide. SDT with labels versus backpatching. There are the two common approaches for translating the Boolean expression. In the first approach, the labels are known and used directly during the code generation. In the backpatching, some jump destination may not be known immediately. So, incomplete jumps are generated and corrected later. Backpatching is particularly useful for the complex expression and one pass code generation. So, SDT with labels uses the predefined labels. This backpatching labels may be unknown initially. Here it is a direct jump. Here generate the incomplete jumps. Simple translation suitable for the complex control flows. Targets the known during the translation. Target filled later. Uses the e dot true and e dot false. Uses the true list and false list. I hope you guys understood. Let us move on to the next line. Advantages, which generates the intermediate code efficiently, supports the short circuit evaluation, avoids the unnecessary computations, produces the efficient control flow, uses the conditional and unconditional jumps, supports the nested Boolean expressions, useful for conditional statements and loops, can be combined with backpatching, supports the one pass code generation. I hope you guys understood. Let us move on to the applications. STD for the Boolean expression is widely used in the different control statements. If it is used in the if statement, if else statements, loops such as while, complex condition expression, whenever a program needs to make the decision based on one or more condition, the Boolean expression translation is required. So I hope you guys understood. Let us move on to the summary. To summarize, the Boolean expression produces either true or false values. SDT associated semantic actions with grammar production. The Boolean expressions are translated into a control flow. E dot true represents the true destination. E dot false represents the false destination, and evaluates the second expression only when the first is true, or evaluates the second expression only when the first is false. Not exchange true and false labels. Short circuit evaluation improves efficiency. Backpatching resolves unknown jump targets. The conclusion is, from the Boolean expression, grammar production, from the grammar production, semantic action takes place, from the semantic action, short circuit evaluation takes place, from it, labels and jump instruction takes place, finally, intermediate code is generated. So, the syntax directed translation provides an efficient technique for translating the Boolean expression into an intermediate code by using the true and false labels, conditional jumps, short circuit evaluation, and backpatching. A compiler can generate the efficient control flow for conditional statements and loops. I hope you guys understood. If you have any doubts, please raise your doubts in the comment box so that I can respond. Thank you.